All right, today we're going to be talking about determinants and inverses of matrices, okay? So just to start off, a square matrix is a matrix that has the same number of rows and columns, okay? 2 by 2, 3 by 3, 4 by 4. Each square matrix can be assigned a real number called the determinant of the matrix, okay? So say we have a 2 by 2 matrix here, okay? We're going to label it A, B, C, and D all in order, alphabetical, right? How would we find the determinant? Well, we would find the determinant by taking A times D minus B times C. Okay, so A times D minus B times C. And what the determinant does for me, okay, what the determinant does for me is it tells me whether or not this 2 by 2 square matrix has an inverse. Okay. If I get a determinant that is not 0, then I can find the inverse of this matrix in this matrix. Okay, but if I get 0, then that means that matrix does not have an inverse. Okay, so in these first two examples here, we're just practicing finding the determinant, right? So just assume this is a 2 by 2, right? So this is A, B, C, and D there, just in order, right? Okay, so define the determinant. So the determinant, so DET, whenever you see DET of a letter, that means I'm asking to find the determinant. We're going to do 1 times 6 minus, because that's A times D, minus B times C. So 3 times 4. So then that's going to give you 1 times 6, which is 6, minus 3 times 4, which is 12. And so then your determinant of A is equal to a negative 6. And that's fine. Our determinant can be negative or positive. It doesn't matter. Okay, so that's the determinant of A for number 1 right there. Okay, so now let's do the same thing for number 2, right? So now we're going to get determinant of A is going to be equal to, again, this is A, B, C, and D. We only use this method with 2 by 2. We're about to do the determinant of a 3 by 3, and I'll show you how to do that. Okay. So we're going to go determinant of A is equal to A times D. So you're going to get a negative 6 times 4 minus B times C, which is 12 times the negative 2. So now just go ahead and simplify that. So negative 6 times 4 is a negative 24. Minus 12 times negative 2 is also a negative 24. So I'll put that in parentheses. And so what happens here when you have a negative times a negative? That gives you a positive. And so you're going to have negative 24 plus 24. And so the determinant of A then equals 0. And in this case, that means we could not find the inverse of this matrix because we got 0. If we get any other value besides 0, then we're able to find the determinant. Then we're able to find the inverse of that function. Okay? All right, now, it kind of shows you I consider to be a more difficult way to find the determinant of a 3 by 3. I've got a shortcut, and so I'm going to show you that method for our next example here, because now we're going to look at a 3 by 3 matrix and try to find that determinant. So, what are my steps? My first step whenever I see a 3 by 3 is I rewrite columns 1 and 2 over again. Okay, so see how column 1 is 3, negative 2, 5. I'm going to write it as 3, negative 2, 5. So I rewrite the first column over again. I'm going to do the same with the second column as well. So the second column is 2, negative 3, 2. So I'm going to write 2, negative 3, 2. Okay. Now, same process, okay, kind of as 2 by 2. I'm going to start in the top left corner. So I'm going to start with this 3, and I'm going to draw a line through these 3 numbers right here. So 3, negative 3, and 3. Okay? So I'm going to go ahead and start my process over here. So I'm going to multiply those all together. So I'm going to get 3, negative 3, 3, plus, go to the next diagonal here now, 2, 0, 5, So 2 times 0 times 5 plus, next diagonal here, negative 1, negative 2, and 2. See how we started in the top left and then we finished in the bottom right? That's how you know you can't go any further. You're always going to have 3 sets of values here. Okay? So that would be negative 1, negative 2, and 2. Okay? Now, not done yet. That's one direction. Remember, we have to change directions. So then when we change directions, okay, I'm going to have a big subtraction sign because we're changing directions. Sorry, I'm running out of room this way. Big subtraction sign, and now this whole thing is going to go in parentheses because of that subtraction sign out front. And now I switch directions. So now I started in the top left. Remember, when we did 2 by 2, you started top left, you did A times D, and then you went bottom left and then did B times C, right? Same process here. So now we're going to start in the bottom left, and we're going to draw a color like this. Whoa, what's going on with my pen? Okay, sorry, it's not working. I'll use a highlighter. So we're going to start bottom left here, and we're going to go 5, negative 3, negative 1. So 5, negative 3, negative 1, plus 2, 0, 3, okay, plus, last but not least here, because we started bottom left, so we have to finish top right, right? So then we're going 3, negative 2, 2. Okay? You've just done the method to find the determinant. Now it's just all about adding this all together, okay? And finding our determinant. So we're going to have this. Let's look on our left side here. So 3 times negative 3, that's a negative 9 times 3 there, that's a negative 27. 2 times 0 times 5 plus 0. Negative 1 times negative 2, that's a positive 2 times 2, that's 4. Minus, in parentheses now. Okay, that's going to give me 5 times negative 3 is a negative 15 times negative 1, it's a positive 15. Plus 2 times 0 times 3, that's just 0. And then we've got 3 times negative 2, which is a negative 6 times 2, which is a negative 12. So then it's going to be something like this. We're going to have negative 27 plus 4, that gives me a negative 23, minus 15 minus 12 is 3. And so then the determinant of this matrix, the determinant of x, is equal to negative 23 minus 3, which is a negative 26. So yes, I can find the inverse of this matrix. Now, we're about to now go over how to find the inverse of that matrix. Okay? Here's our formula. Okay? To find the inverse of a matrix, and it's denoted as this. When you see big A raised to negative 1, I'm asking you to find the inverse. Okay? This is why we have to do the determinant. It's 1 over the determinant. Okay? And now look what happens here. Normally let big A equal A, B, C, and D. Look what happens here now. We're doing 1 over the determinant times. We're switching A and D's position. And then we're changing B and C's sign. Okay? Now, you always want to find the determinant first, because if you get a determinant of 0, then you know you cannot find the inverse. It's impossible. It's not possible to get the inverse. Okay? So, let's look at these examples here. So, first thing, find the determinant. So, remember, A, B, C, and D here. So how do I find the determinant? It's A times D. So it's going to be 2 times 3 minus B times C, which is 4 times 1. That gives you 6 minus 4. Then you know the determinant of A is equal to 2. Okay? So the determinant of A is equal to 2. So that means I can find the inverse of this function. Okay? So let's go ahead and let's do that. So we're going to get this. We're going to get 1 over the determinant, which is 2, right? 1 over the determinant times. Now we've got to change stuff in my original matrix. Remember, look what's happening here. A and D are flipped. So now the 3 goes up here in the first diagonal. 2 switches. Remember, A and D flip. A and D flip. And then all you do with B and C is you just flip their signs. So this is just going to be a -1 and a -4. Now to finish this, all we're going to do now is the scalar multiplication. This is why we learned scalar multiplication. You're just going to take this 1/2 and multiply it by all these numbers. And so we're going to get this. I don't want decimals, I want the actual fraction, okay? So 1/2 times 3 is going to give me 3/2. 1/2 times a -4, -2. 1/2 times a -1, -1/2. And then 1/2 times 2 is 1. And this right here is your inverse. This is A to the -1 right here. So to recap that, find the determinant. We found to be 2. Okay? Once we found the determinant, we then plug in our formula. We do 1 over the determinant equals, we switched A and D, and then just change the signs for C and B. They don't switch, their signs just change. They don't change positions. All right, let's look at this second example here. Again, we've got a 2 by 2, so remember A, B, C, and D. So let's go ahead and find the determinant, A times D, so that's going to give you 3 times 4. Minus B times C, so -6 times a -2. So that gives me 12 minus 12, which equals 0. So our determinant, A equals 0. That's a problem, because look what happens when you do 1 over the determinant. Anything over 0 is what? We said it's undefined, right? So it's not possible for me to find the inverse here. So no inverse exists because determinant of A is equal to 0. So make sure you know how to explain yourself for that. Make sure you know how to explain yourself. Okay? So, how to find the determinant, why you need to know the determinant, because it's going to help you to determine if you can find the inverse of these matrices. Okay? All right. Let's move on to the next part of the notes. Okay? The identity matrix. Okay? The identity matrix is just a square matrix with the first diagonal always being 1. So a 2 by 2 would be 1, 1 down this first diagonal and the rest zeros. Look at your 3 by 3. Your diagonal from the top left to the bottom right is all 1s. Everything else is zeros. Okay? What the identity matrix does for me is it tells me that two matrices are actual inverses of each other. Okay? So, if I was to take this example here, right, okay, and multiply A times B and get my identity matrix, and then do B times A and also get my identity matrix, then those two matrices would be our actual inverses of each other. Okay? So let's show that. So let's look at this for example. So again, here's my identity matrix. This is what I'm trying to get. When I multiply A times B, I want to get this. If I don't get this, then I know that they're not inverses of each other. Okay? So recall again, this is a 2 by 2. This is a 2 by 2. Right? So then we know our product, when we multiply here, is equal to a 2 by 2. Okay? So let's go ahead and draw our solution matrix. Okay, remember, I only care about the rows from the first matrix. Let me see if I have another colored pen so I can show you guys this. Sorry. Okay, perfect, I do. Okay, so remember, when doing matrix multiplication, I only care about the first row. I only care about the rows from the first matrix, the columns from the second. So I'm going to go ahead, I'm going to label row 1, row 2 here. So row 1, row 2. And then I'm going to label just the columns for the second matrix here. Column 1, column 2. Okay? So here we go, right? I'm looking at, oh, sorry, I forgot to label the columns down here on my product. Okay? So I know my first element comes from row 1 on the first matrix and column 1 on the second matrix. Okay? So watch here, right? Okay? I'm taking the first element in row 1 times the first element in column 1. So I'm going to do 2 times 5. Okay? Plus, now the second element in row 1 times the second element in column 1. So 3 times a negative 3. For this element right here, it's now row 1 times column 2. So I go back to row 1. My first element in row 1 is a 2. My first element in column 2 is a 3. So we're going to go 2 times negative 3 plus the second element in row 1 now times the second element in column 2. 3 times 2. Okay? Now we're moving down here. Row 2 times column 1 for this element. So now I'm looking at row 2 only in column 1. So the first entry in row 2 times the first entry in column 1. So that's going to be a 3 times 5. Okay? Second element in row 2, second element in column 1, 5 plus 5 times the negative 3. And then now I'm looking at row 2, column 2. Okay? So first element in row 2 times first element in column 1. So that's going to be 3 times the negative 3. So 3 times the negative 3. And then 5 plus 5 times 2. And now let's just go ahead and simplify. So that top up there, you're going to get 10 minus 9, so that's a 1. Negative 6 plus 6, so that's 0. 15 minus 15, so 0. And then negative 9 plus 10, positive 1. So yes, we did get the identity matrix for doing A times B. But we can't stop there and just assume that these two are inverses of each other. We now need to do B times A. Okay? So, when we do B times A, order matters now, right? So I'm going to go ahead here and I'm going to write out now B first. So 5, negative 3, negative 3 and 2. And then A, which is 2, 3, 3 and 5. Notice how I switched order. Order does matter with matrices. It's saying B first, then A. Matrix multiplication is not the same when you switch orders. Perfect example, right? Like if I told you, okay, yeah, what's 4 times 7? You tell me 28, right? Well, then what if I did 7 times 4? That's also 28. right? Order doesn't matter with multiplication with just normal integers. Okay, with matrix multiplication, that is not always true, that you're going to get the same solution. All right, so it's very important that we understand. So now we're going to do the same process again. Remember, we've got a 2 by 2 here and a 2 by 2, so we know my product is going to be a 2 by 2 as well. Remember, my numbers match up. I have the same columns as rows. So now I'm going to do the same thing. I'm going to label this row 1, row 2, and then column 1, column 2. Remember, I'm only concerned with the rows in the first matrix, columns in the second. So I'm going to go over here now and I'm going to draw my 2 by 2 product matrix. Make sure I have enough space to fill in all my work. Okay? And so on my product matrix, I label just the rows from the first matrix and then the columns from the second. And now here we go. Okay, remember, row 1 times column 1. So 5 times 2 plus negative 3 times 3. Okay? Row 1, column 2. So first element in row 1 times first element in column 2. So I'm going to go 5 times 3 plus second element in row 1 times second element in column 2. So negative 3 times 5. Okay, row 2 times column 1. So we're going to go negative 3, okay, times 2 plus second element in row 2 times second element in column 1, 2 times 3. All right, last element here is row 2 times column 2. So we're going to go negative 3 times 3 plus second element times second 2 times 5. And now let's just go ahead and simplify and see what I get. So we get 10 minus 9, which is 1. 15 minus 15, 0. Negative 6 plus 6, 0. And then negative 9 plus 10, that's a positive 1, so yes. So since I got the identity matrix for doing A times B and B times A, these two are inverses of each other. They're inverses of each other because AB equals BA equals the identity. This is true because I got the identity matrix for both. Okay? So now if we were to do the same thing down here on number 2, same process again, right? So I'm doing G times H and then H times G. So again, I only care about the rows from the first. 2 by 2, 2 by 2. Can we perform matrix multiplication? Yes, we can, because the columns of the first matrix match the rows of the second. Columns of the first match the rows of the second. So therefore, my product is going to equal 2 by 2 because you take the rows from the first, columns from the second. Okay, so let's draw out our product here, matrix. Give me some space. And here we go. So we're going to go row 1, row 2, column 1, column 2. And here we go, same process again. We'll go a little bit quicker this time because we've been doing this now for 3 days. So 4 times 2 plus 3 times the negative 3. So that's row 1, column 1. Row 1, column 2. So 4 times 4. See, first element in row 1 times first element in column 2, so 4 times 4. Second element in row 1, 3 times the second element in column 2, negative 4. Okay, row 2, column 1. So row 2, column 1, so 4. First element in row 2 times first element in column 1, which is a 2, plus second element in row 2, so 2 times the second element in column 1, 2 times the negative 3. Okay, and then last but not least, row 2, column 2 here. So we're going first element in row 2, so 4 times the the first element in row 2 times the first element in column 2, so 4 times 4. And then the second element in row 2 times the second element in column 2, so we're going to do plus 2 times negative 4. Okay, let's go ahead and simplify those now. So that's going to give me this. You're going to get, in the top there, you're going to get 8 minus 9, so a negative 1. 16 minus 12, so 4. 8 minus 6, 2. 16 minus 8, 8. So we did not get the identity matrix here by doing G times H. So therefore, we don't even need to test H times G. G times H did not give us the identity matrix. We don't need to test HG. So GH equals HG does not equal the identity matrix. Therefore, they are not inverses. And make sure you know how to show that. Okay? All right, last one, and you're going to need to have a calculator for this. You're going to need to have a 36X or a graphing calculator to perform this. Okay? To do a 3x3 inverse, okay? To do a 3x3 inverse, it's way too long to do it by hand. So this is where you're going to be allowed to use your technology. Okay? So, first off, we need to find the determinant. All right? So, how we're going to use the calculator is this. Okay? I'm going to turn my matrix on. I'm going to turn my calculator on my matrix. Okay? I'm going to hit the second button and see where it says matrix right here above the math. I'm going to hit that. Now, notice what I have here. So, I did second math. Okay? I'm going to go all the way over to edit. And I've got, and if you notice here, sorry, let's go back. So second matrix, look, I've got names, math, edit. Okay? So I've got a couple options here, right? I've got A, B, and C. Okay, so I can write in 3 matrices at a time. So I'm going to go to edit, I'm going to select A, and now what do I have here? I have a 3x3. I have 3 rows, 3 columns. So I'm going to go I'm going to go to 3. Oh shoot, sorry, hit edit, go back there, hit A. I'm going to go over to 3, hit enter. See how the 3 is highlighted now? Go over for columns, 3 as well, hit enter. Okay, and now it's going to give me a blank 3x3 matrix. Okay, it's giving me a blank 3x3 matrix, and now I'm going to plug it in. Now, the only issue that's going to cause us problems with this is if you do not plug your matrix in correctly. Okay, so you're just going across, you're just doing 2, enter. Negative 3, enter. 2, enter. Okay, 1, enter. Negative 3, enter. 0, enter. Negative 4, enter. 7, enter. 1, enter. Okay? Now, sorry, I know there's a little bit of glare there, so let's go ahead and let's match it and see if we've got it correct. So mine does look to be good there. Okay? So again, how did I do? I hit second math. I went over to edit, and now look it. if we hit second math again, we should now see a 3 by 3 matrix there for A. Hit enter, and there you go. There's your matrix. So 2, -3, 2, 1, -3, 0, -4, 7, 1. Okay? All right, so the first thing we always need to find is we need to find the determinant, because if the determinant is not 0, then we know there's going to be an inverse for this matrix. Okay, so here's what we're going to do. We're going to do second mode to quit. It's very weird why we have to go all the way back out and come back in. But for some reason, we can't calculate the determinant and the inverse without doing this. So we're going to hit second mode quit. Okay, it's going to get me back to my original screen, blank screen. When you turn the calculator on, you're going to go to second matrix. Now, we want to find the determinant first. So when you go to math, you notice how your first option there is determinant. You're going to hit, so you go to second math, you scroll over to math, and you see your first option there, determinant. You're going to hit enter and see how now a DET comes up. Okay? Well, now all I need to do then is I need to pull that matrix A from the edit. So I'm going to go to second math again, and notice now instead of going all the way to edit, I'm just going to go to names and see how under names there, matrix A is my 3 by 3 matrix that I created. I'm going to hit enter there, close parentheses, hit enter, and there you go. So I just found the determinant to be -13. So yes, this does have an inverse. This does have an inverse. So how do we go about doing that? Well, okay, all we're going to do is this. We're going to go back. We're going to go second math, and I'm going to select that A again, enter, and now look at my symbol there. What is my A being raised to? A -1. So I'm going to hit my exponent button here and just raise it to a -1. Hit enter. And there you go. So there's your inverse. Look how ugly it is. Now, ideally, I want it to be in fractions. I want it to be in actual fractions. Okay, so what I'm going to do here is I'm going to hit this squiggly button and see if it'll convert it all into fractions for us, our inverse matrix. And there you go. It does. Okay, so we've got to be careful though when we write it that we got to scroll over some of these because we can't tell what the fraction is just by looking at it right now. Okay, so my answer is going to be this then. Okay, it's going to be a 3 by 3. It's going to be 3 over 13. Scroll over there. That's -17 over 13. Okay, -6 over 13. Okay, 1 over 13. Sorry, guys, there's your pencil. -10 over 13. Pretty sure, yep, -10 over 13. And then -2 over 13. 5 over 13. 2 over 13. And then 3 over 13. And there you go. Okay, so if you're struggling with this, rewatch this portion over again about how to do this, because when you're asked to find the inverse of a 3 by 3, you have to use the calculator. Way too extensive to do it by hand. Okay, it takes way too long. You wouldn't have time to finish on a test. All right. Now, if it's a 2 by 2, like on the practice right here, I expect you to show your work, like how we did on the problems on the first page of notes. Okay? But that is it today for the lesson. I'm hoping the next time I see you guys is back in class. We're all together on Monday. But great job this week. I appreciate all the hard work. And have a great weekend. And I'll talk to you in class on Monday. Thank you.